All right, howdy everyone. We're going to calculate some limits using algebraic conjugates. And remember, algebraic conjugates are when you have something like a plus the square root of b, and its conjugate is a minus the square root of b, and vice versa. So those are called algebraic conjugates. You can often recognize when you need to use this technique when you're doing limits, because you'll have a square root in there of the form sort of a plus the square root of b. All right, so the example we're going to do here is to calculate the limit as x goes to 4 of x squared minus 16 all over the square root of x minus 2. And you can see we've got this square root of x minus 2 in there, and so that gives us a big clue that algebraic conjugates should be handy. All right, so let's go ahead and get going. So the trick is to multiply by that algebraic conjugate. So you take x squared minus 16, leave it alone, square root of x minus 2, leave it alone, and multiply now by the algebraic conjugate. So that'd be the square root of x plus 2. And the square root of x plus 2. All right, so on the bottom, we see that when you multiply these two things together, you're going to get the square root of x squared, so that's x minus 2 squared, so that's a 4. The square root of x we're just going to leave there, and the x squared minus 16 will factor. So that'll be x minus 4 and an x plus 4. Okay? And now you see we've got good things going on because we're canceling the x minus 4s. Okay, so what's left is the limit as x goes to 4 of x plus 4 times the square root of x plus 2. And since x is going to 4, this whole thing is converging to 8. And since x is going to 4, this term has to converge to the square root of 4, which is 2. So the whole thing will converge to just 2 plus 2, which is a 4. So anyway, we see that we get an 8 times a 4 from this, which is 32. And that's the answer. All right, that's all. Ciao.